Artie.
What's up? I don't know. I was just joking. I wanted to give Carter Canini and a pencil. Thank you.
You're welcome.
I couldn't add. This was homework, right? Should be submitted.
Should have already been submitted, yes.
No, I did on this one.
Okay. So, in preparation for tomorrow's quiz, you have 2 graphs. Let's look at the first one from the quiz review. Okay, what are we going to do? You tell me. What are we doing? Before we stop talking, unless you're being productive towards us. If it's in the denominator, yes. I don't think you have to do it in the numerator. Does that make sense? So it's not going to steer you wrong, but it's not really necessary, so you choose to. Find the horizontal asymptote. Okay, how am I going to find the horizontal asymptote? First off, what's the coefficient of the x in the bottom? 1. And what math am I going to do? I'm going to divide 2 by 1. Everybody good with that? So y equals 2 is my horizontal asymptote. If my function was like x over x squared plus 4, they're not equal to each other. Where's the larger degree, numerator or denominator? Denominator. So what would the horizontal asymptote be in that instance?
0.
Good. Y equals 0. So when they're equal, you divide. When the denominator is greater, y equals 0. When the denominator is numerator is greater than 1, we'll go through that in a second. All right, so y equals 2 is my asymptote. Now I'm going to look at my denominator. I have an x. That means x cannot be equal to what? In my denominator, what can my denominator never be equal to? 0. So that means x cannot be equal to what? 0. You're being recorded right now as you talk, just letting you know. Don't put it on the internet. People are going to bully you. They're going to cyberbully you. Then they're going to super cyberbully you because you're talking to them. So it's not. What? Whenever it's just x, so whether it's like this or when it's factored out, you add 0 to your list of points to this number. Make sense? Okay, so how many vertical asymptotes do I have? 1. How many points do I need to plug in? 2. 1 on each side. Baby. 1 on each side. You're bleeding. Okay. So over here in terms of work. I don't need to see all this. I don't need to see x-intercept and y-intercept. As I discussed with Gavin yesterday, I just need to see the point. What are those points going to be? If my vertical asymptote is at 0, what are those points possibly going to be? 1 and -1. Is everybody good with that? So all you need is 1 point to the left, 1 point to the right. And this is going to be up on Google Classroom, so you don't need to take photos right. So 1's on the left, 1's on the right. So I'm going to say 1 and -1. Could it have been 2 and -2? Could it have been 2 and -1? Yes. Could it have been 1 and 2? No, because they're on the same side. And all I'm doing is plugging those values in. When I plug in 1, my numerator is 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. My denominator is just x, so that's 2. What's 4 divided by 2? 2. So that means 1, 2 is on my graph.
What are the problems before?
Hold on. 6. That's my bad. 6. And what's 6 divided by 2? 3. So 2, 3 is on my graph. I apologize. Or 1, 3. What's up, Jeff? I'm plugging 2 in. Up top, 2 times 2 is?
No, it's only 1.
Oh, why am I plugging in 2? What's 1 times 2? 2. 2 plus 2? 4. 4 divided by 1? 4. We'll get there. So 1, 4 is on my graph. Good now? So how am I going to draw my graph? I'm now going to what? Hug the asymptote. Now I'm going to do the same thing and plug in what? Negative 1. What's 2 times negative 1? Negative 2. What's negative 2 plus 2? And 0 over anything is? Okay, negative 1, 0. There we go. Good? Good? Now I look at the bottom. The degree of the numerator is 1. The degree of the denominator is 2. The degree of the denominator is greater, so therefore my asymptote horizontal will be y equals 0. Everybody good with that? That's my horizontal. Now I have to figure out my vertical asymptotes. To do that, I factor my denominator. What does x squared minus 9 factor into? X minus 3, x plus 3. Everybody good with that? Now, Dylan, this is when you're going to factor the numerator. Make sense? Because you want to see if something cancels out. So now you're going to pull out the negative 3, and that becomes x minus 1. So when you have to factor the denominator, then you factor out something in the numerator as well. Does that make sense? Okay. Now, I have negative x minus 3 in the denominator. What's the opposite of negative 3? Positive 3. So that's one of my vertical asymptotes. I have x plus 3 in my denominator. What's the opposite of positive 3? Negative 3. So I have that as an asymptote. So the difference with this one, instead of 1 asymptote, I now have 2. So instead of 2 points, how many points do I need? 4. Everybody good with that? Those 4 points could possibly be 4, negative 4, negative 2, and positive 2. Does that make sense? Because 2 are on the left, 2 on the right. Does that make sense to everybody? I'm going to make one alteration. I'm going to change 2 to 1. Because if I look at my factored numerator, what's the 1 minus 1 going to make my numerator? 0. And 0 over anything is 0. The first what? That's my numerator. So that's, if I factor that out, and what are you asking me? This is 4. 4, negative 4, 2, and negative 2, and 1. Does it have to be 1? No. Can you still do the graph if it's negative 2? Absolutely. So now I'm going to plug in 4. You can plug it in either to this, or you can plug it into that, whatever is easier for you. Negative 3 times 4 is what times 12? Negative 12. Negative 12 plus 3, negative 9. 4 squared, 16. 16 minus 9, 7. Negative 9 sevenths, feel free to estimate in your calculator. It's about negative 1.3. So 4 negative 1.3 is there. Can you then create your graph from that, on that side? Yes. What are you going to make sure you hug? Because they always need hugs. The asymptotes. Now if I plug in negative 4, negative times a negative is positive. So that gives me 12 plus 3, which is 15. Negative 4 squared is 16. 16 minus 9 is 7. So negative 4 gives me positive 15 over 7. So that's about here at 2.1. Does that tell me where that graph's going to go? Yes. That makes sense to everybody, the outside. So the outsides are just like when there's one. They can't cross the asymptote. The insides can. So, I got negative 2. Negative 2 times negative 3 is 6. 6 plus 3 is 9. Negative 2 squared is 4. 4 minus 9 is negative 5. So negative 2 gives me negative 9 over 5, which is here. Now, when I plug in 1, 0, where am I at? I'm at the what? Asymptote. Alright? So that means I'm going to do 2 instead. So now I'm going to plug in 2. Negative 3 times 2 is negative 6. Negative 6 plus 3 is negative 3. 2 squared is 4. 4 minus 9, negative 5. Negative over a negative turns into a what? Positive. So that's 3 over 5. The positive is very important because that tells you the shape of the inside. Do you have 1 point underneath and 1 point above? That means you have this shape. And you're done. It can cross the asymptote in between. It cannot cross the asymptote outside. If when you plot the 2 interior points, they're on the same side, instead of that shape, what are you going to have? A U. Okay? Sound good? Everybody good? Okay. Now, let's go over the last part of the